So we're gonna switch from process monitoring products to our environmental monitoring products. I believe this is more relevant to you guys, since you guys are in touch a lot with local agency, private industry that need to monitor their chimney, their emissions, to figure out if there's any air pollutants that is emitted from their factories. So I will start today's training sections. Okay. So again, so today we're gonna talk about our ambient gas monitorings. So if you guys have any questions, feel free to reach out to me after today's trainings, or during the training section. If you have any questions, let me know. Feel free to pause me or stop me. I can answer your questions right away. So again, EPMs, that is including our EM and PM. So today we're gonna focus about our EM products, which is environmental monitoring. So the whole idea was to design and manufacturing two analyzers that we're able to monitoring our gases or a particular pollutants. Today's we're gonna more focusing on the gases part, which is more related to NOx, SOx, CO, CO2, methane, or VOC, etc. So of course, this technology can help the customers to monitor their air pollutants emitted from their factory sites, or it can ensure their process, or they can, it can improve their efficiency. They can heat up their ovens or heat up their furnace to increase their pollutant removal rate, so to reduce any air pollutants emitted from their workspace, or also other application is to monitoring their worker safeties, any hazardous environments that we try to measure any pollutants that might cause threats to human health. So if you there are several different factories that we can order our analyzers from. The main factory is Franklin and China. That's where we usually import our gas analyzers from. So when we talk about ambient air qualities, that kind of involve many other factors or any other elements in the monitoring scope. That is including the gases, including CO, CO2, methane, ozone, SOx, NOx. So those are the standards compounds or standards elements that we need to measure. Other than the gases one, there's another part called particulate matters. That's where, having a lot of issues recently, say, PM 2.5 can cause can reduce our lifespan of the humans, or, can cause any health effects. So we're gonna cover that sections in the next training section for our particulate matter monitorings. Today, we're gonna just talk about the gas. As you can see, if you go online, go to a lot of ambient monitoring websites, or maybe National Environmental Protection Agency, they have all those information listed out. So we're able to know, what are the air qualities? Is it safe to go outside? Is any hazardous issues that occurring in our airs? So our analyzer is able to produce those data to the customers or to the general public to know, if there's any hazardous threats that is in the environment. So as you can see here, as I mentioned earlier, the United States, a lot of country, I believe Vienna has those regulations. They are called National Ambient Air Quality Standards that has six principal pollutants criteria. We so-called criteria. as I listed out, carbon monoxide, SO2, NO2 or NOx, NOx, ozone, O3, particulate matter, PM2.5 and PM10, and lead. We're gonna cover those sections in the different training sections. As you can see, this is a great way when you go approach your customers. You can tell them, hey, those compounds right here can cause any threat, health concerns. All of those need to be measured. All of this need to be focused. So for applications, how do we approach the customer? How do we upsell or sell our analyzers to what industry or what applications? First, this is the most common one. It's called AQMS, Air Quality Monitoring Stations. So a lot of government agency, they will want to set up their stations at different provinces or different industrial park to monitor any pollutants that is emitted from the industrial park or other residential areas, or maybe city downtowns where there's a lot of scooters, a lot of traffic that can cause any air pollutants. Other than that, at the private sectors, there are some heavy industry that they might need to focus on their source emissions, such as power generations, coal-fired power plants, natural gas-fired power plants, petrochemicals like refineries, chemical production sites, plastic production sites. Other than that, paper mills, other heavy industry that might emit CO2 or CO. Those are the great way we can sell our solution to them. Other than that, cements, where they produce cement factories, cement industries. Other than last but not least, waste incinerators, or where we burn our trashes, burn our garbage, rubbish. That of course we need to measure how well is the incinerator is operating, is able to remove all of those hazardous pollutants from their systems, and then without emitting to our atmosphere. So this is some photos for AQMS site. The setup is quite similar to our SIM systems. So back to where I'm talking about is in here, we call our applications AQMS, Air Quality Monitoring Stations. And here, source emissions, we call it SIMS, Continuous Emissions Monitoring Stations. So all of those stations, they equip the same analyzers that we produce or we promote. So as you can see here, we put our solutions, our analyzer into a cabinet. All of those analyzers are single compound analyzers. They analyze one particular compounds, CO, methanes, SO2, NOx, etc. As all of this, they using a heating sample line, has a pump behind it, constantly drawing airs from the atmosphere or from the chimneys. The solution right here on your right hand side, it's combined with the gas analyzers with our PM, particulate matters monitoring analyzers here, PM 2.5, PM 10 analyzers here, and rest of it, it's a gas analyzers. Other than stationary AQMS application or solutions, the customers can also install our gas analyzers or PM particulate matter analyzers into a car, like a van or any kind of truck. They can move this truck around to the sites or to where the hotspot is to measure the air qualities. So as you can see here, this is a mobile AQMS solutions that we install analyzers in here. And then as you can see here, there's a chimneys that constantly drawing airs into the analyzers. They can do monitorings. They can move this turnkey solution around to the locations or to where the industrial park. They can do a screening on the air qualities around the park. So the reason, when the customer come into us say, hey, why do we choose Thermo Fisher? Thermo Fisher has first invented the key, sorry, the chemical imluminescence analyzers that is focused on NOx analyzers. So when the US EPA designed these regulations, we are actually first to comply with this law because we are the first inventors to invent that solution that fits this methods or technology. So the solution has been out in the world for a long time since 1970s. Today, we are leading manufacturers supplying a wide range of environmental gas analysis equipment throughout the whole world. So we do have a really strong market shares. All of those analyzers has been evolved or upgrades every 20 or 20 years. So we have already have about 3 generations that was able to provide to the end users. So we in every countries that currently have environmental monitoring programs, most of them are using Thermo Fisher's products, or all of them are using Thermo Fisher's products. As you can see here, this is the diagrams or a scheme for how we set up our air monitoring systems. So we do have a we do have a pump systems behind us constantly drawing airs. We set up a manifold that we're able to split into different channels or different stream that is focused on one particular parameters, that is NOx, SOx, THC, that including methanes or non-methanes, CO and CO2. We do have other necessary accessory that need to be incorporated or including in this SIM systems, that is called multi-gas calibrators and zero gas suppliers. So later in the slide, I will introduce and tell you guys what are the technology behind the gas analyzers, what are the purpose of using the multi-gas calibrator or zero gas suppliers. Other than that, we can also set up a PM10 or PM2.5 monitor with this SIMS monitoring systems. Of course, the layout or the inlet port will be designed differently, but they can all combine it together become a SIMS solutions or AQMS solutions. So right here on your right hand side here, this is a technology or methods behind how do we calculate or how do we detect our NOx or nitrogen dioxide compounds. So we are using a chemiluminescence for NOx, pulse UV fluorescence for SOx. For CO and CO2, we're using a IR gas filter corrections. For ozone, we're using UV photometers to do the detections. For THC, we're using the FID, flame ionization detections. For the methanes and non-methanes, we're using the gas chromatography, so-called GC. So about 10 years ago, I'm sorry, in 2017, we upgraded from our I series. So in 2017, we upgrade from our previous generation I series to our IQ series. Later, I'm gonna tell you what are the difference and then to do a really quick comparisons. But as right now, we still able to provide I series and also IQ series. For I series, it's been well known. We still have a lot of users, so we cannot obsolete this generation right away. But our newer generation IQ is still on the market. We're still able to promote. Depends on the functions or depends on how the customer choose their analyzers. I'm gonna do a quick launch videos for our IQ series. Please take a look. Okay. So as you can see from the launching videos, there are some features that is, different from our older generation I series. First, it has a intuitive graphic user interface that is touch panels. You're able to select different features, different settings, just by touching the touch panels. All of these settings, calibrations, all the instruments accessibilities can be done through these touch panels. You can do a quick calibration backgrounds, zero span schedules. You can do a zero spans, and also you can go back and check what are the results and what are the readings of each seconds or each times. We have a data log that is well built into the systems that you're able to see what are the data trend within the last 24 hours or last hours or last years. Depends how you set up the instruments. As you can see here, you're able to see the trend charts. You're able to see the different concentration at different moments. All of this can be done through these touch panels. So it's easy to access. It's so intuitive. It's user friendly. Other than the older generation, the new generation IQ series, it has a function to predict diagnostic to let the end user know when do they need to do maintenance, the lifetime or lifespan of any particular consumable that need to do changed. They can send out email to alarm the user, say, hey, something goes on. We need to do a quick diagnostic. We need to swap certain parts in our systems. Also, it has a remote control abilities that you can use our app to know what are the reading and now. So the engineers don't have to go on site. They don't have to go to the AQM stations. They can just put up their smartphone and to check what's going on with the analyzers, what are the reading, what are the concentration at right now at this moment. You can see there's maintenance alert, resource page, contact page. They can use their phone to reach out or send requests to our Thermo Fisher engineers or thermal fisher customer service sites. They are able to send out the help or send out any troubleshooting materials to the end user. They has the newer IQ series has 4 USB ports. The customer can use their thumb drive, USB thumb drives, to download their data log or to do a firmware upgrades using this USB port. It has Ethernet cables that are able to upload the data through Modbus systems, so it can be 24 hours, 7 days, 360 days of data submitted to their central systems. It has a quad-core processor, about 8 gigabytes of memories, so they are able to collect data constantly without any failures. So this is a quick comparison with our old generation to the newer generations. As you can see, the memories is increased. The user interface is getting better, and it's touch screens. There are more firmware upgrades with. There are USB connectors compared to the old one. They have none, so they have to use Ethernet or other cables to download their data. The speed for transferring data is much faster. Rest of it, they kind of stay the same. But one thing I want to point out is the capability to use your smartphone to check your instruments away remotely. So I just finished about the quick configuration or comparison or overview of our gas analyzers. Right now, I'm gonna just go into the concept or methods of how do we detect the gases in different gas analyzers. So first, we do have a 17I. This is 17I is for ammonia gas analyzers. Typically, you will see this in incinerators or other gas manufacture sites where they produce ammonia as a product, such as air product, air liquids, etc. Other than that, probably SIMS, continuous emission monitoring might use this. Depends on what the customer is looking for. If they are using ammonia gas analyzers, 70I is our to go. They can measure from sub ppb levels up to 100 ppm. They are using the same technology, same methods as the way we detect NOx. So it's all chemiluminescence technologies. So the operation principles, they have 3 modes. One is NO mode, means nitrogen monoxide mode. Second mode is NOx mode. Third one is NT. That means we convert ammonias into NO. The reason we need to convert the gases into NO is because when we give NO a certain energies, it will light up, and then detectors are using the chemiluminescence, the energy to calculate the proportion to our to become our concentrations. The second analyzers I kind of constantly mention throughout the presentation is the SOx analyzers. I'm sorry, NOx analyzers. This can be used for NO, NO2, and NOx analyzers. Of course, different configurations, we're able to measure from sub ppb levels up to 100 ppm levels or even higher. So as you can see here, for same as our 17I, there's NO mode and NOx mode. So nitric oxide NO and ozones can react to produce a characteristic luminescence to light up with the intensity linearity proportional to the concentration. So the infrared lights emission results when electronic excited NO2 molecules, and then it decays. So we are using those changes between the decay of electronics and also the decays of intensity of the imluminescence. We're able to convert this convert these signals into concentrations. Okay. For nitrogen dioxide, how do we do it? So we must convert this into NO by molybdenums. This is a materials that are able to heat up, I think, to about 1,000 degrees, that will convert our nitrogen dioxide into nitrogen monoxides, and then we use nitrogen monoxides immunogenicities to detect their concentrations. So when we take in the samples from the atmosphere, the sample will go into these capillaries. So small trace amount of gases will go into here. Depends on how we set up our analyzers. If we want to measure NO, it will go bypassed into this chambers that we able to do. We able to generate ozones to react with this NO, and then the difference, as so the NO lights up, and then we use our detectors to detect the difference to do a quick proportion to our NO concentrations. For on the other hand, if we want to do a NOx mode, that means we are introduce all the gases all together. The NO2 will convert, the NO2 and NO will convert into all together into NO, and then we use a similar way to do the calculation to do analysis, and then we subtract out the NO. Then we will know how much is the NO2 and then how much is the NO. So that's how we do the NO2 readings and NO readings, and also NOx reading. NOx means we plus the NO2 and NO all together. That will become our NOx readings from the atmosphere. Other analyzers that are able to do SOx analyzer is our 43i or the 43IQ. Again, they are using a light technology. So we excite our SOx SO2 in the sample gases. So the SO2 molecular absorb UV ultralights and it become excited at one wavelength. And then after they excite, it decays to a lower energy state. And then they emit a UV lights at a different wavelengths. Then we calculate the different wavelengths, the amount of signals to convert into a concentrations. So again, this analyzer is able to measure from sub-ppb level all the way to ppm levels. As you can see here, our sample is coming here into our analyzers here. They have this called HC kickers. This is a mechanism that is able to absorb all the total carbon hydrates. So all the THC will be absorbed in this hydrocarbon kickers. All the remaining will be the SOx and the SO2. The SO2 will go into these chambers, and then we emit UV lights into these chambers and to excite this our SO2. And then we have the signal process able to calculate the difference, and then we will know what's the concentration of our SO2. We have this analyzer, it's called 450i, similar to our 43i. The only difference is because it's capable of to measure H2S. They are using the same technologies. They are able to measure from sub-ppb level to 100 ppm levels. So what we're able to do is inside this 450i 450i or 450iq, it has a converters or catalyst that able to convert our H2S to become a SO2. And then we measure the SO2 similar to our 43i. We shine a UV light and excite the SO2, and then you will emit another UV lights at different wavelengths, and then we do the calculation and our analyzers. We're able to do the whole SO2 calculation or the H2S calculations. Next, we have our 48iq. This is our CO analyzers. The technology behind this is a gas filter correction technologies. We can go from sub ppb level all the way to percentage levels. The reason we use gas filter corrections is because carbon monoxide absorb infrared radiations at wave numbers at 4.6 microns. And the infrared absorbance is a linear measurement technique. So we're able to know it's so linear, we're able to know the concentration versus their signal intensities. Inside this analyzers, we have this called gas filter wheels, GFCs. I will show you in the next slide. Also the concept behind this technologies. So as you can see here, we shine our infrared source at 4.6 microns wavelengths through this copper filter wheel. Inside this wheel, we have nitrogens and CO2. So when the lights go through nitrogens, none of the absorbance will be IR lights will be absorbed. So we capture this the intensities at these detectors. If the gas cells is full with the CO compounds, the sample gas filled with CO compounds, the light will go through here and then will be absorbed. When we flip this copper filter wheel around where it fills with CO, all those infrareds will be absorbed, and none of the IR lights will go through this filter wheel. So when these detectors, when they do the signals, that will become zero because the IR light is absorbed. So we can do the difference between with nitrogen's copper filter wheel and with CO copper filter wheel, and then we'll calculate the difference, and we will know what are the concentration here or gas CO gas in the gas cell. We will use this intensity to do our calculation to convert into concentrations. So this is the diagrams of how we do the samplings. Sample will go through here and then go to this permeation dryers into this gas cell. The copper, the CFW is here. IR lights will shine through here into our gas cells, and then we will switch this the mechanism to change from nitrogens where the IR can be will not be absorbed and go through the systems, or we can switch back to CO where all the IR is absorbing here and calculate the difference. The detectors absorb the signals, and then we can calculate into our CO concentration. Again, for CO2, similar technology as our CO. We're using the optical filter technologies because carbon dioxide the wave number is different. It's at 4.2 micron. So similar, we just change our IR source to emit 4.2 micron of frequency. Well, sorry, the wavelengths. And then we have this gas filter wheel to change it around to filter out the 0 and hundreds of our intensities, and then we can do the calculation using our detectors. The next one is our ozone analyzers. The technology is UV photometric technologies. It can go from ppb levels up to 200 ppm. The operation principle is because the ozone molecule can absorb UV lights at wavelengths at 254 nanometers. So we excite our ozone and let it absorb those energies. And once it decays, it will shine the lights. And then we use the lights to calculate the proportional to our concentrations. So again, this is the configuration of our 14 to 49 IQ. The sample will goes in. We have we have mechanisms called ozone scrubbers. So once the sample goes in, it's split into two streams. One string will go into the cell 1 or cell 2. Another one will go into our ozone scrubbers that we remove all the ozones from the samples. We burn, we scrub it out. We remove from the samples. Then this string will go into the second cell here. And then we calculate the difference between the cell 1 and cell 2. So we will know the concentration between the cell 1 and cell 2 to calculate to convert into concentration of our ozones. The system will alternate around. So we constantly introduce the the gas without ozone into one chambers. Sample going to another chamber. We kind of switch it around to have a better ratio, to have a better accuracies of how do we measure our ozones. We have other calibrations. Oh, I'm sorry. We have other calibrators or zero gas suppliers. The reason we need to do a calibrator is because we still need to introduce a known concentration into our systems so we can do adjustments between any fine tunes. So we do this all the reason we choose this because US EPA has this regulation say you need to have a multi-gas calibrator on site to do a quick QA and QC check to make sure your analyzer is able to produce the readings that is correct, accuracies, and also precision. We do have it's called 111 IQ or 111's I. This is a zero air supply. So we deliver a pollutant-free levels of NO, NO2, ozone, and SOx into our system as we require. So all of this, when you propose a AQMS stations or AQMS stations, a SIM solution proposal to your end users, not only need to including the gas analyzers, but also you need to have these calibrators on site. Also zero air supplier on site to make sure all of these analyzers is able to meet the QA and QC procedures. So as you can see here, this has been updates of January 2020. We have our SOx analyzers, NOx analyzers, SOx analyzers, CO and CO2 and ozone calibrators and gases. All of this, as you can see here, we have 42 IQ HL. This HL means high levels. TL means trace levels. So if the customer is looking at something that trace level, PPB levels, this is the configurations that you want to promote, you want to propose. HL means high levels. When the customer is looking for somewhere around higher ppm, 100 ppm, 1000 ppm to percentage levels, then we would choose this the HL configurations. For PS, that means primary standards. So this is for the ozone primary standards that we set up to the customers. So I'm gonna do a really quick recap of our analyzers, gas analyzers. For our IQ series, we can do a real-time monitoring. All the information can be uploaded through our user interface, so you can do a remote controls. It has less troubleshooting times. All of those analyzer is being modularized. If some part is broken, we can simply swap the module out and replace a new module, such as motherboard, pump, the UV emitting modules, etc. All of this can be swapped easily. It is easy to operate. Everything has a user interface that's touch panels. You can set up all this directly through the touch panels. It's easy to maintenance. Once installed, we can do analysis right away. You don't have to do method development. All of this is preset when we select our configurations. So this is our solution to monitoring any ambient pollutants, including SOx, NOx, CO2, and ozones. I want to just give you guys a quick tour to the slide and also to our website. Give me a second. Second. So as you can see here, we have this Thermo Scientific 42 IQ. If you scroll down here, this is what configurations we want to discuss with the customers. They have different, of course, they have different voltage. Does the customer need an analog or digital outputs? Does it need a I/O D2 output to the central servers? Does it need a Ethernet or does it need all? So this will help us to know the configurations. If you go to our Thermo Fisher website, if you go to our Thermo Fisher's website here, we'll scroll down. It has a specification sheet. When you open it, it will tells you all of those information that we need. For instance, if we are looking for 43 IQ sulfur dioxide, how do we order it? We just simply fill up these symbols. What are the power core you need? Does it need a communications? Does it need any case configuration that is needed? You just simply fill it out. 43 IQ dash B A C or B A D, depends on the configurations. Then this is your configuration for this particular analyzers. When you talk to the customers, you can show them here under our specifications. They can go from 0 to 100 ppm or 0 to 200 milligrams per meter cube. Depends on how we set it. How do we set up the parameters? All of the specifications such as drift, positions, linearities are all listed out. So this is a really good resource when you start want to having the conversation with the customers. This will help you to navigate all the questions that the customer have. If the customer needs any I/O, analog digitals, or any serial number, any serial ports, this is the configurations that specification we have for our analyzers. And different analyzers will have different ordering code. So this is our specific charts, the data sheets will help you or guide you to select the right configurations. But if you guys have any questions, feel free to reach out to me. But first, I will definitely have you to go through this configuration first to discuss with the customers. And then we would figure out is this is the reasonable or this is the right configuration for the customer. Do you guys have any questions regarding to the gas analyzers? Hello?
Hello, Ivan.
Okay, so I just finished the gas analyzer trainings. If you guys have any questions, please let me know. But first you can go to our website, Thermo Fisher's Scientific. Figure out which analyzers you want to promote. SOx, NOx, SO2, ozone, and then have the data sheets prepared for the customers. They can just simply choose which parameters they need to use, and then we can start the conversation with them. For applications, not only SIMS or AQMS, some customers that they want to measure their CO2 in their gas streams or from the emissions from automobiles. Those gas analyzers are perfect for monitoring such applications. So as long you have the customer's interest that fits our parameters, SO2, NO, NO2, CO, CO2, THC, methane, ozone, we are able to promote our I series or IQ series to customers. All of these analyzers are the same configuration. Everything can be put into a 19-inch enclosure or 19-inch rack. So when you do the promotion, it will look really nicely into the one cabinets. Okay, so I'm gonna wrap up today's training section for our gas analyzers. If you guys have any issues, questions, feel free to reach out to me. I will prepare the presentation. I will send it to Mr. Long. You can have this presentation to promote to your end users.
Okay, thank you, Ivan.
Okay, thank you.
Yeah, thank you. So you can stop your recording now. So yeah, I just want to talk to CAA team.
Sure.
Yeah. Anh Long ơi,